Hi everyone, welcome back to the workshop, and it's repair and refurbishment time again, and I've got another old bench power supply, this time a Thurlby 30V 2A. Now this particular unit is not marked down as being faulty, I just know it's in a pretty bad state. So we're not going to power it up, we're going to take the cover off and let's take a look inside. Let's do some quick electrical checks before we actually put power into it. So this unit's pretty similar in construction to the Thurlby unit. It's got a large transformer in the middle, a couple of large electrolytic caps, we've got some transistors. I can see through the back here, the 2N3055 transistors again on the back with the heat sinks, and a display control board at the front there. And we've also got a little board down here mounted vertically off the bottom, and it appears to be the bridge rectifier. It's got at least 5 diodes, a resistor and a capacitor. So we'll do some checks on that also. So let's get the meter out and we'll start checking out the transformer, and let's check those diodes as well. So it appears to be multi-tapped on the primary side. I think this is the incoming windings, and it appears to be okay there. Let's just check it down to earth. Yeah, that looks safe enough. So I think this is one coil here on that primary. Let's see. Yep, and I think this is the other one. Yep. And on the secondary side, looks like we've got two windings. We've got a centre tapped winding and a single winding. So the single winding, 1.65 ohms. 5.3, 4.5, dancing about a little bit there, and the centre tap. On the other side, let's go across that outer one again. Yeah, 1.75. Okay, and let's just check them down to earth. Yep, that transformer looks safe enough. And let's check the diodes in that small board down here. Yep, 0.4. 0.4, yep. Point 0.5. Let's see if I can get down into those other two. 0.4. And 0.4. Yep, they look okay. And the next thing, I want to take the back off and let's take a look at those transistors. I can see at least a couple and it's pretty dusty in there. And here we go. Looks like we just got a little cover. Not acting as a heatsink, it's just a little protective cover here. And we've got a couple of 2N3055s looking quite clean actually. It's ones down inside that look really quite dusty. So I'm going to take off this outer heatsink and expose the ones below. And we'll do some checks on those transistors. Well, these are quite slack actually. So we've got two transistors mounted on the outer heatsink. And it looks like we've got another two possibly mounted on the inner heatsink, but on a little PCB here. Quite interesting. I wonder if there's any extra components in there, or perhaps it's just a way of connecting all the wires between the transistors. But anyway, let's check out the actual transistors and see if they're actually intact. So let's go into the base emitter of this one first. And yeah, it's not showing too good, and that could be that the other transistors or the actual control board circuitry is actually biasing the test. So it looks like I'll have to desolder this wire here and this one here, and let's isolate the base on both of those transistors. Okay, wires removed, let's retest. That's more like it, 0.5 of a volt. And the base collector, yep, that's the same. And the other transistor, base emitter, Oh, bad connection there. Yeah, 0.5 of a volt, and the collector 0.5 of a volt as well. That's perfect. And the inner heatsink. Yep, I've got another two N3055s. So let's see if we can test them. Right, I think this is the base emitter. Once again, the other transistors or the control circuitry is getting in the way. Yeah, I think we'll just take a chance that they're okay. I don't really want to remove that PCB. So the next thing I'm going to do is I'm going to actually blow it out with the air line inside the power supply and down the back here of these actual heat sinks here, because it is completely dusty. It's quite a mess. Well, that's it blown out, and to tell you the truth, it didn't make much difference because the dirt in the bottom of it is actually ingrained onto the bottom, and it really needs everything stripped completely out in order to give it a good clean up. And I think that's what I'm going to do. I mean, it's a pretty worthless power supply at the end of the day, but I do like a good refurb job to keep my hand in on the workbench, so I'm actually going to go ahead and do that. But first things first, I'd like to power it up and let's see if it actually works or if it needs repair. So I've assembled the heat sinks back onto the back. Let's power it up and see what we get. Right, let's power it up and see what happens. Looks like we've got a dodgy LED over at the left hand side, the voltage display. We've got a digit missing, or it looks all over the place. The current side might be working. And when you switch the channel off, you get all decimal points there. Is that on purpose? Oh, that's for setting the current. Wow. Don't often see that in an old power supply. Let's check the output with my meter here. Let's wind it right down. Oh, the output, not really working. Screw it right up to top. I'm getting about 0 to 20 volts, so no, it's not really working well, is it? Yeah, definitely something wrong, not working properly. Well, let me put power on. I'm going to check the rectified DC across those capacitors. So that's power back on again. Let's take a look here. 54.7, reasonably stable. And 54.7 there as well. So yeah, that looks okay. So I think the next thing I'm going to do is I'm going to take off the control board and let's take a look at that top side of it and all the components, and let's see what we can spot there. Well, it looks like the front panel can be removed. It's actually detachable from the base with two screws on the underside, and it looks like the front panel board I can just easily remove from some screws on the front panel itself. So let me go away and do that now. And here we go. Multiple wiring looms down onto the front panel for all the controls, and also the loom here going away off back, obviously the power supply, and going to the output transistors. And here is the top side of that board, and you can see immediately you've got a couple of large ICs. Well, these are basically DVMs in a chip, and it can drive directly an LED display like you can see here. So we've got a couple of them, one for voltage and one for current, and you can also see down the middle here we've got a rather large resistor, 0.5 of an ohm. That's the main shunt resistor for measuring the current output. We've got an op amp down here, an LM358. That will feature heavily on the schematic when we come to that. That's your main control chip for the voltage and current modes. You've got a 4011, a 4000 series CMOS chip. That's a quad NAND package, and a 4007 4000 series CMOS chip. That's a dual complementary pair driver IC. So it's a fairly simple circuit. Let's take a look at the schematic. So up at the top left hand side here we've got the transformer, then a couple of bridge rectifiers, so there's going to be two supplies at least. We've got a 7805 regulator there, TO220, that's the 5V supply for the display and control logic. Another winding here on the transformer, that's the main output, which will be obviously directed to the output bananas via the control circuit. So you can see those two ICs here, you can see we've got the bus here going away off to the actual LED displays here, the voltage and the current, and then you've got the control side, the input side to that chip, your 200 millivolt I think it is, coming from the op-amp circuit up here. This is a classic design. You've got an op-amp here for the voltage setting and you've got an op-amp here for the current setting, and they meet together with these two diodes here, and the lowest voltage output wins. So if the voltage set is lower than the current set, then that's the voltage that goes away off to drive the buffer transistor here, which drives the main transistors at the top there. But the current op-amp can clamp that voltage down just by setting its output lower than the voltage one, and you can see this diode will then conduct and pull that voltage down, then you're in current limit mode. So it's a classic design. Down at the bottom here you've got the actual LEDs, as I mentioned, bust off from the IC, and you've got 4 transistors here. Those are for the column drives. I think they're common anode LEDs, so therefore your column drives are switched down to 0 volts. And the same at the current side, and you can see you've got some logic involved with that 4011 NAND, and there is the 4007 there as well. And so we've got enough here to try and troubleshoot the problem with that voltage display. Is it the display problem itself? Is it a problem with the IC? And on top of that, have we got a problem with the control op-amp? Because it didn't look to be displaying anything near a nice stable voltage. So something's oscillating up and down somewhere. Okay, ready for a power up. A nice bit of cardboard underneath the board to protect the underside. Everything looks safe. The 5V regulator is just under there. Not sure if you can see that. The TO220 package standing off the board, and this aluminium plate here is its heatsink that's also used to steady those LEDs. So I can get my negative for the meter on the screw of that TO220, which is attached to the tab. And let's turn on power. And yet we've got the same fault here as before. As you can see, we're getting a digit missing there, and it just seems to be jumping around, especially this most significant digit here. So first things first, onto the 5V supply. I'm just going to go into the supply pin of this 4007 CMOS logic IC, and you can see that 4.98, perfect. And I'll just try the op-amp as well. Yep, 4.98, and its ground pin is sitting at -6 volts. Wow, let's take a look at that on the schematic. So the 5V supply is not straightforward. If you look at the circuit here a little bit closer, you've actually got a center tapped winding on the transformer. One side's giving us a positive output, and the other side is giving us a negative output. Now you can see that the 5V regulator I was measuring there was indeed giving me 5 volts across the regulator, but you've got a diode forward biased on the ground pin of that regulator down to 0 volts, which is the center tap on that winding, and that's going to give us about 5.7 volts for the plus VE output here. The negative VE is just a simple Zener diode. There's its resistor there. Not sure of the value of that Zener diode. So let me go and pick up the new ground point, which will be there for the ground point for the entire logic. And let's measure that positive VE and minus VE. So there we go. Not sure if you can see that, but I've soldered on a bit of wire onto the star ground point, which is just the cathode side of that diode I was looking at off of the 7805, and you can see all these tracks, all the ground points from the various parts of the circuit all coming back to that star ground. So I'll use that for my multimeter. So let's go across that op amp again, which is across that plus and minus VE. So there's my 5.7 volts, and on the negative side, but minus 5.9. That's probably okay. Like I said, not too sure of the size of that Zener diode, but it looks stable enough. So what I'm going to do is I'm going to go across the op amp and let's see what the output of both sides of that op amp are doing. Like I showed earlier, one is the current side and the other is the voltage setting side. So let me put power on. And let's go to the current output, pin 7 of that op amp there. 5.24 volts. Now remember, lowest voltage wins. So let's go into pin 1, the voltage side. And it's jumping all over the place. Now lowest voltage wins, so the voltage should be going straight through to the DVM effectively. But as you can see, it's jumping all over the place. Hence the display's jumping all over the place. Now I think this digit problem we've got here has probably got something to do with the actual output from the chip itself. But let's try and get this analog stable first. So let's take a look at the positive output banana. And let's see what we're getting there. And we're getting 0. And let's take a look at the negative output banana. If I just reach under. Oh. And it's jumping all over the place. That's why that's jumping all over the place. So let's take a look at the circuit diagram again. So there is the output bananas up here, and you can see the sense terminals. Now they're linked externally on the front of the power supply, so no problem there. But if you look at this negative side here, there's the negative output, and it's looped back onto that sense terminal, and it comes all the way back down to here, and that is the voltage, coarse and fine pots which are in series. So you can see the output voltage, the negative side, is fed back down into this control circuit here. You've got a series of resistors and pots here for calibration, and that op amp there as well. So something is causing this op amp to become unstable. And now one other thing that you do have, this DVM chip here actually has a reference voltage input. And you can see that on pin 18 here. And follow up, and you've got a Zener diode and a resistor off of the plus VE rail, that positive rail coming from the 7805. So with this resistor and Zener diode set up here, it should be a nice stable voltage there. So let's take a look at that. So let's take a look at the current side first. Pin 18 of that chip, 2.4461, nice and stable there. Let's go on to the voltage side, and it's jumping all over the place. Now it's either loaded up or something wrong with that setup there. And there is a Zener diode there, one on the voltage side, and its opposite number on the current side over there, and it's a ZN404. That's a precision 2.5 volt Zener diode. Well, temporarily I just swapped over the two Zener diodes, and the problem stays at this side. So it's not a breakdown of the Zener in any way, and so something else is loading up that Zener diode and causing it to lose its reference voltage. So I'll need to dig a little bit deeper. Well, as luck would have it, I've just fixed it. As you can see, the voltage display is a lot more stable. Now what did I do? Well, I did two things. I swapped back the ICs, the main IC, the ADD3701, I swapped them back over, and I resoldered a joint on this potentiometer here, the voltage adjust pot. Not that it looked bad, I had just taken the wire off so that I could measure the resistance of that pot, and then I soldered it back on because it was fine. And when I powered it back up, it's working. So either the socket there has got a dodgy joint in it, or perhaps a dodgy joint in this pot. But no matter what I do now, I've tapped around the board, tapped the components, wiggled the wires, and I can't get it to fail again. So looks like we're halfway there. Now at the moment we've still got a dodgy digit there, it's not working at all, but if you can imagine it's 0.56, and if I just adjust the coarse pot upwards, there we've got 1 point something 25 volts, and keep going up, 2 point something, nice and stable there if I stop doing anything, and keep going all the way up to 30.28 volts, and it is a 30 volt power supply. Well, I'll take that, but I would have rather have known exactly what was wrong. And if I measure the control output on that op amp there, pin 1, you can see that it's nice and stable now. And if I adjust the voltage adjust pot back down the way again, you can see it's changing, no problem at all. Stop there, yeah, 0.599, perfect. And the voltage reference on that 3701 that we'd measured earlier, 2.5 volt, well, yep, 2.4449, and it's stable. And back onto the other one, just to compare, 2.4702. So the next thing we need to fix is that dodgy digit there. So to troubleshoot that dodgy digit, here is the LED itself, and there is the column drive for the 4 digits, and it's driven from the actual main 3701 IC. So I'm going to scope the pinouts that drive the bases of those transistors, and then we'll scope the collector. But first things first, I'm going to do that on the working side first, let you see what the base of those transistors look like. Right, so pin 15, 16, 17, 18, 19, 20, 21, there's the first digit. You can see we've got a square wave there, because remember it's a multiplexed LED. And you can see the voltage is going up and down a little bit. That's obviously just coming from the chip itself. And the next pin, the next digit, it's the same. The third one, it's the same. And the fourth digit, well, it's got a lower voltage. Now bearing in mind that none of the decimal points are lit on that current display, so I suppose that voltage there must be okay. So now onto the voltage LED, the chip there, measuring the base again. Pins 15, 16, 17, 18, 19, 20, 21. There's the first digit. Well, that's okay. The second digit, that's okay. The third digit, oh, a higher voltage, but it's okay. And the fourth digit, again, same as the current display, it's just a lower voltage for some reason. But all 4 are outputting okay. So it's not like we've got a dead output driving one of those transistors. So the next thing I'm going to do, I'm going to measure the base of each one of those transistors one at a time. Let's make sure the signal's reaching the actual transistor. So I think that'll be the fourth digit. It's back to front this time. That'll be the third one. Wow, look at that. That's not right. And this third one, that looks okay. And that looks okay. So yeah, going back to that one there, definitely got a problem there. That looks like it's floating to me, possibly. So there's the 4 transistors there, and it's this second one in here, and the base has got a top side soldered pad. So I'm going to check out that track. I'll have to do it off camera to get my head right in there and see if I can find out if there's a break or something like that in that track between the IC itself and the base of the transistor. Right, so I've traced back all 4 bases of those transistors, and they wiggle their way all around back on the underside of that PCB there, and down to 4 track pins, which is a pin that's used to link one side of the PCB to the other. And this is in the days prior to through-hole plating. So it's those 4 track pins there. And this third one along here from the left is the one in question. And all it's got to do is on the underside of the PCB link about 2mm onto the pin of the socket. Now if I measure the base of the transistor to the top side of that track pin, I've got a good connection. So the problem is on the underside. And there are those 4 track pins there, and you can see they're soldered pretty well onto the socket of the IC. So I'm just going to resolder the joints here. It doesn't look too bad. Possibly we've got a dodgy solder joint there on that one in question. And given that I found a problem with the socket anyway, it looks like I'm going to have to resolder all of the pins on that socket. So I'll go away and resolder that, and then I'll come back. Right, all pins in that IC soldered up. Let's switch it on. Yes! It's working! That was the problem. So let's adjust the voltage adjust pot in the front of the panel. Yes! And I've got a nice decimal point there as well. All the way up to 31 volts. Perfect. So that was the problem all along. 2 pins on that IC socket. One was causing the digit problem, and the other one was causing the stability problem. Wow. So let me put back down that LED. I've got a new sticky fixer here, which I'll just put in place. And try and align it up. There we go. And a quick power up again. Yep, no problem. Well, that's it back together again. I basically took everything out of the middle section there where all the transformer and capacitors are in order that I could hammer the chassis straight because it had a nice bend in it. Got that done, cleaned all the dirt out that was on that base plate there on the chassis there, and put it back together again, cleaned up the front panel, and I noticed the fine control knob wasn't working, so I've replaced it. And I've also replaced the output sense terminal jumpers that were hanging down below, and I've just replaced them with some large copper wire there, so it looks a lot neater. The next thing I'm going to do is I'm actually going to repaint the actual cover and the back panel, but I'm not going to do them brown. Nah, just not my colour. So I've still got some enamel paint left over from the last power supply I refurbished in my last video, and it's anthracite, so I'm just going to use that, and I think it'll look quite good. Okay, quick test on the output. I'm going to hook up the electronic load and let's just test and see it works under load and that current limit works. So let me just put those there, and I've got the electronic load hooked up off camera, so let me just connect it in here on the main output. Right, I've got the electronic load set up for a 0.5 amp, so let me just turn on the electronic load and yes, 0.495, so that's near enough 0.5 amp, and the output voltage seems stable enough. Could probably do with a little bit of a recalibration, but I'll do that off camera once I let it soak test for a while. So let's just set a current here. Let's set it to 400 milliamps. Turn it back on and turn on the electronic load. And yes, it's clamped it down. And wow, yes, the decimal points flash when it goes into the current limit mode. I didn't know that. So if I just adjust this up again, yep, it recovers and the output comes back on again. Looking good. So it's a 2 amp power supply, so let's just wind it all the way up to 30 volts. That's good enough. And I've got the electronic load now set at 2 amps. I've got the current limit at its maximum. I'll switch on the electronic load. And yes, it's handling the 2 amps just fine. So let's try the damping switch now. So let's just turn it on, and that should damp the current readout. So if I now turn on the electronic load at 2 amps again, you can see it's a lot slower at climbing up to that 2 amps. So that looks like it's working, no problem. Well, there it is, all completed. cover on, all painted up and looking pretty good. And I think the front panel's cleaned up quite nicely as well. So this is another power supply repair that possibly will see its way onto some workbench somewhere, some technician somewhere, who knows. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.